Well, hi everybody. All right, well, I have this little video for you. We're just working on connecting the graphs of quadratic functions, the parabolas you get, to the solutions. And I'm just going to start out with an equation. If we had this equation, and we just took a test where we did problems like this, where we solved x squared minus 3x minus 10 equals 0. All right, well, I'm multiplying two numbers to get negative 10 and adding to get negative 3. And you'll notice that 5 and 2, if one of them's negative and one of them's positive, and let's make the 5 negative because negative 5 plus 2 is negative 3, that we'll come up with the numbers we need. And we would have x minus 5 times x plus 2 equal to 0. So that means x minus 5 equals 0, or x plus 2 equals 0. And if I add 5 to both sides here, I get x equals 5. If I subtract 2 from both sides here, I get x equals negative 2. Alright, so there's my two solutions. Well, now what I'd like to do is have you try the same thing. Let's graph y equals x squared minus 3x minus 10. Let's graph that. So when I go to graph that, I'm going to first of all get the axis of symmetry. The x equals negative b over 2a. And remember, a is 1, b is negative 3, and c is negative 10. And double negative 3 over 2 times 1. I got 3, that's positive 3 on the top, over 2. I got 1.5 here. So I'm going to make a table of values. I think I want to try 7 values in this table. And I actually may go more. And let's see. Let's go 1.5. Let's go 1 below it. And then 0, negative 1, negative 2. And then I'll go 2 here, 3 here, 4 here, and 5 here. And plug that in to x squared minus 3x minus 10. I do know that I'll get my vertex in this coordinate here. Let's see. Oops, that's clear. Let's just get out of this. Clear. So I'm going to put this in parentheses and go negative 2 squared minus 3 times negative 2 minus 10. Ooh, I get 0. And that is very interesting to know. But we'll go with that in a second. Now let's put in negative 1. Let's type in a negative 1 here. Negative 1 here. And what do we got? Negative 6. If I put 0 in, I'm talking about the y-intercept. That's negative 10. I just know if that's 0 and that's 0, then negative 10 is all that's left. Okay, I'm going to put 1 in, which means I'm just going to delete the negative signs off of here. Delete. And delete. And I get negative 12. And at 1.5, okay, there's a thing you can do here. You can insert, which is the second function of that delete button. So hit 0.5 and then move your arrow over. And then I'm going to go second and insert and go 0.5, and go there, hit enter, I get negative 12.25. Okay, I am going to go with the fact we are on the same distance from, this is the vertex, and this would be negative 12, negative 10, negative 6. I'm just getting it from the table here, guys. And 0. And I'm going to make this graph. Let's see. I kind of go over here with my y-axis. Let's go over here with my x-axis and just start plotting some points. So negative 2, 0, negative 1, negative 6, 2, 3, 4, 5, 6 is here. 0, negative 10, 7, 8, 9, 10 is down here. 1, negative 12 is here. 1.5, negative 12.5 is right here. 2, negative 12. 3, negative 10. 4, negative 6. 5, 0. What are we going up here? 4, 6. I almost think I could go up, if you look at the pattern, 2, we go up 4, we go up 6, the next one we would go up 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to do that without putting it into the table. 1, 2, 3, 4, 5, 6, 7, 8. Alright, I'm just going to draw our parabola that comes out of here. Okay, so there's my parabola. And if you will notice, at 1, 2, 3, we noticed in the table, 4, 5. At 5, we hit 0. At negative 2, we hit 0. And do you recognize that those, the x-intercepts, these are called the roots. They're called the zeros. They also are the x-intercepts. But these zeros is one of the more common, well, roots is also terms that are used. When you set your function equal to 0, where it's hitting the x-axis is the actual solution, 5 and negative 2. So I wanted you to see that connection. Let's do one more. Let's do example 2 here. Negative x squared minus 8x minus 16 equals 0. Negative x squared minus 8x minus 16 equals 0. So I'm going to make, well, the first thing I'm going to do is just try to solve it. And what I'm going to do is multiply this thing by negative 1. Multiply the whole equation by negative 1. Well, multiply both sides. Let's do it that way. Multiply both sides by negative 1. And negative 1 times negative x squared is x squared. Negative 1 times negative 8x is positive 8x. And negative 1 times negative 16 is positive 16. And 0 times negative 1 is still 0. Okay. Now, let's look at what multiplies. It's just a little easier to deal with without that negative being the first. But what multiplies to 16 and adds to 8, and I think we'll see 4 times 4 and 4 plus 4 is going to do the trick here. So when I factor that, that's x plus 4 times x plus 4, and that is equal to 0. So x plus 4 equals 0, or x plus 4 equals 0. It's the same thing. There's no sense of writing it twice, so we got x equals negative 4. All right, now let's connect that to the graph of, let's draw it like this. Okay, let's, we're going to graph y equals negative x squared. Let's use the original. Minus 8x minus 16. And a is negative 1, b is negative 8, and c is negative 16. A is negative 1, b is negative 8, and c is negative 16. So when we do x equals negative b over 2a, it's negative negative 8 over 2 times negative 1. And that's negative 8. No, it's negative 8. That's positive 8 over negative 2, which is negative 4. So x equals negative 4. That is our, I'm going to put my table right here. I'm going to put it right here. Negative 4. I'm going to make that the middle of my table here. X equals negative 4. I'll go smaller. Negative 5, negative 6, negative 7. Those are smaller because it's negative. Let's go negative 3, negative 2, negative 1, and 0. Right there. And let's figure out values in this. Okay, I've got to put a negative and then a paren, and negative 7, the c's, squared, minus 8, paren, negative 7, the c's, minus 16. All right, and that's negative 9. And I'll go second, enter, and replace the negative 7s. Let's just type right over the 7s and put 6s in their places. Save a little time. I'm seeing negative 4 there. Negative 5, second, enter. Negative 5, negative 5. I'm getting negative 1. Let's put in negative 4. Negative 4. There. Negative 4 there. That is 0. Okay, let's put in negative 3. If that is, we figured that to be where the vertex is at negative 4, 0. So this should be negative 1, this negative 4, this negative 9. I do know 0 is the y-intercept, and I think with this equation that would be negative 16. But let me put in negative 3 just to make sure. Yep, that is negative 1. I'm going to go ahead and go with the negative 4 there and the negative 9 there. So negative 7, 1, 2, 3, 4, 5, 6, 7. Negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 is right there. Negative 6, negative 1, 2, 3, 4 is right there. Negative 5, negative 1 is right there. Negative 4, 0 is there. Negative 3, negative 1. Negative 2, negative 4. Negative 1, negative 9. Alright. And then it hits the y-axis way down here. So I'm just going to kind of start up here. and draw my parabola. Now this one, we only got the one answer, if you'll recall. We got x equals -4. 1, 2, 3, 4. Right here, we have -4, 0. So we have a 0 that is -4, and that is matching our equation that was set equal to 0. So there's the connection, guys. Just take this down, and we will get ready to practice hard on this on Monday. Okay, you guys have a marvelous weekend.